In this video, I want to talk about the states of a process. A process is not always running, being executed in the CPU. It goes through a series of states. The states are dependent on the operating system, but more or less they follow this diagram. And I want to show it to you. So first, when we launch a program, remember when we execute a command, then the process starts, and it must be admitted or not. Why not always, not each time that we run a program can be executed. For example, we can't have enough memory available, we can't have enough permissions to run it, or whatever. So when it's admitted by the operating system, it it goes its state is ready. So in this point, remember, if this is memory. At this point, we have here the process. Let's call process one, and the operating system has created a process one in the table in the process table. But it doesn't mean that the program is being executed. It's here, it's waiting. There is a queue here. We have a queue with an scheduling algorithm, and here at some point it will be program one. Then after some point, the scheduler will pick this process to to execute and to occupy the CPU. So the scheduler algorithm, imagine that we have run all this program and it's P1 turn. So it goes to the CPU and it is running. So this was ready. It's available to execute to being executed, and here when it's in the CPU, it's running this state. And then after that, after some point, well, the process is not here in the CPU forever. What can happen? Well, for example, a timeout. Let's say that the operating system decides that a program can run from 10 milliseconds, and then okay, timeout. Then you go to the queue again because I need to put another process here. So in this case, the process will return here to the queue, and after some time, the scheduler will pick it again for being run. So this is running, but while a process is running, imagine we have here in the CPU we have process one. It can't perform an input-output operation. So for example, imagine that program one needs to write something or read something to disk. This is an extremely slow operation, and it's useless to have the process here waiting until, for example, the hard drive returns the data or whatever. This is an input-output event or other kind of event. For example, you can sleep for a couple of milliseconds. When that happens, the process is removed from the CPU, but in that case doesn't go to the queue for with all the programs ready for being executed, because we can't execute this process again until the input output operation has finished or the event has finished. So it goes to a waiting queue until here. Then the process goes here to this state to wait until the input output operation of the event is completed. In that case, for example, imagine that okay, you have the data here waiting for you, then it will return to the queue, to the ready queue, and wait again until the scheduler picks the process one to run into the CPU again. So more or less this is the the status of a process. One ready, then run for a little bit, Then you have you after a timeout you go ready, running ready. You perform an input output operation. Then you wait here until the input output operation is finished. Then ready again and run a little bit, ready, run a little bit. And after some time, the program will exit and it will be terminated, and we have finished the operation for the operations with this process. It will be removed. Remember, we have the process table. We will remove the process control block from here because it's not needed anymore, and well, the process is dead, and we have finished to execute whatever we needed to run here. So those are more or less the states of a process, and there are some operating systems with some there are specific states from some operating system, but more or less the idea is this: reading, running, waiting for an input output operation, and finished.